In section 9.6, we are going to look at what is called the chain rule, and specifically a sub-rule of the chain rule called the power rule that will allow us to do derivatives of quantities being raised to a power. When you think about a function that is a quantity raised to a power, that function is actually the composition of two functions. For example, if I have f of x equals the quantity of 3x squared minus 6 being raised to the fourth, that is the composition of two functions that we're going to call u and v, where y equals u to the fourth and v equals 3x squared to the sixth. In this case, our composition occurs because we put the v function in where the u was. It's one function being put inside of another. The formal wording for the chain rule says if f and g are differentiable functions, remember differentiable means has a derivative, with y equaling f of u and u equaling g of x, then define the composite function y equals m of x to equal f of g of x. Then y is a differentiable function of x, and m prime, the derivative, will be f prime of g of x times g prime of x. We are going to use a specific sub-rule of the chain rule that's called the power rule. So if you have y equals u to the n, where u is a differentiable function of x, then dy dx. Now dy dx is just a different way of writing derivative. It means exactly the same thing as y prime. Equals n, now look what happened. N was the power up here, now it goes down to the front. U stays the same, then we do n minus 1, just like we were doing earlier. And then you take it times du dx. U was the function that was on the inside. So you do the power rule to the outside and then take it times the derivative of the inside. For our first example of using the chain rule, we are asked to find the derivative of the function f of x equals the quantity of 7x to the fourth minus 6x squared plus 8. I just want you to see how this is a chain rule problem. If we had u to the negative 3 and then had v equals the 7x to the fourth minus 6x squared plus 8. We put this v into that function where the u is. When you have a function inside a function, that's when you are using the chain rule. So the chain rule says that you do the derivative of the outside part first. Our derivative then starts by bringing the negative 3 to the front. Leave the inside the same right now. So the inside stays 7x to the fourth minus 6x squared plus 8. The same power rule we already know goes into effect here. So we do negative 3 minus 1 and get negative 4. Once you've done the derivative of the outside part, the power part, now you do the derivative of the inside function. So we're going to do the derivative of the polynomial 7x to the fourth minus 6x squared plus 8. That will give us 28x cubed minus 12x. The derivative of 8 is 0, so that's the derivative of the inside. You can just leave this as it is here. If you really, really want to, you could take the -3 and distribute it here. You cannot distribute it on the quantity to the power because you cannot distribute when there is a power on your quantity. On example B, it may not look like a quantity to a power when you first look at it. Here's where some of your algebra skills come into play. What you have to remember is that a fourth root is the same thing as a 1/4 power. So we rewrite this as the quantity of 3x plus 4 being raised to the 1/4 power before we even start the derivative. Now when we have quantity to the power, we are ready to find the derivative. Our rule says to do the outside part first, do the power part. So we're going to drop 1/4 to the front, leave the inside the same, take 1/4 minus 1, which would be the same thing as doing 1/4 minus 4/4. So your new power is -3/4. And then take that times the derivative of the inside, which is 3. Now, in this case, when you have a single number out front and a single number on the end, you should go ahead and multiply those numbers and rewrite this as 3/4 times 3x plus 4 being raised to the -3/4 power. On example C, we are given the function f of x equals 3 times the quantity x cubed minus 5 being raised to the 5th over 5. What you need to recognize on this problem is how it could be rewritten. This could be rewritten as 3/5 times the x cubed minus 5 to the 5th. So in this case, we do have a quantity to the power, and this time we actually have a coefficient out in front of that. When we do the derivative here then, and do the derivative of the outside part, remember what we did earlier when we had coefficients. We just kept them. So we're going to keep our coefficient, and then we're going to do times. Now do the power part, drop the 5 to the front, leave the inside the same. New power goes down by 1, so it will become 4. And then you take that times the derivative of the inside, which is 3x squared. 3/5 times 5, the 5's cancel, and you're left with 3 times the 3x squared on the end, so you get 9x squared times the x cubed minus 5 being raised to the 4th. Remember, you do not distribute that because of the power. You cannot distribute when there's a power on the quantity. On example D, we have y equals 7 over the square root of x squared plus 2x. There's a couple things that we have to do here before we can do the derivative. First, we have to recognize that the square root is a 1/2 power. So it's x squared plus 2x to the 1/2. Secondly, we can't use the power rule, the chain rule, until that 1/2 power is in the numerator. So we need to rewrite it, the function, as 7 times the quantity of x squared plus 2x. Remember, when you move something to the numerator, it becomes negative. You change the sign of the power. So it's -1/2. Now we finally have the right format to be able to actually do the derivative. So our function's name is y, and I'm just going to use that new format of derivative, you can write dy dx. This is saying the derivative of the function y where the variable is x. When you have the coefficient, you just keep it. Times, bring the power to the front, -1/2. Inside stays the same right now. Do -1/2 minus 1, or -1/2 minus 2/2. That's going to give you -3/2 as your new power. Now times the derivative of the inside, which will be 2x plus 2. To clean this up just a little bit, we're going to take the 7 times the -1/2 and get -7/2 times x squared plus 2x to the -3/2. Now notice on this last item that there's a 2 in each term. So I'm going to factor out a 2 there, which would leave me with x plus 1. Now look at what's going on. We've got -7/2 times 2. That will then simplify to be -7 times the quantity of x squared plus 2x being raised to the -3/2 times the quantity x plus 1. On example 2, it says find the equation of the tangent line to the function at x equals 2. So here is question 1. Then it says find the values of x for which the tangent is horizontal. So this is question 2. Notice, however, that both of them are dealing with tangents. As soon as you start talking about tangent lines, you know that you need the derivative. So the first thing we're going to do is find the derivative of this function using the chain rule. Drop the 4 to the front, leave the inside the same. Power goes down by 1 to become 3. Take it times the derivative of the inside, which is just 3. Clean it up by taking the 4 times the 3, and you get 12 times 3x minus 5, the quantity to the third. So now we know that this is the formula for the slope of the tangent. For question 1, we are supposed to find the equation of the tangent line to the function at x equals 2. Remember, in order to write the equation of a line, you need the point and the slope. Right now, we only know the x-coordinate of our point. In order to find the y-coordinate of the point, we have to put the x-coordinate into the original function. So we'll have y equals the quantity of 3 times 2 minus 5 to the 4th. Well, 3 times 2 is 6. 6 minus 5 is 1. 1 to the 4th is 1. So now we know that our point is x value 2, y value of 1. To find the slope of the tangent, we are going to put our x value into the derivative. So it'll be into 12 times 3 times 2 minus 5, the quantity to the third. The quantity is again going to be 6 minus 5, which is 1 to the third is 1 times 12 is 12. We're going to go into point-slope form for the equation of a line. The y of our variable stays as y. The y value of our point is 1 equals 12 times x variable minus x of the point is 2. So we have y minus 1 equals 12x minus 24. Add 1, you get y equals 12x minus 23. So this is our equation of the tangent line, which is the answer to question 1. Question 2 says, find where the tangent is horizontal. Remember that a line that is horizontal will have a slope of 0. So if we're talking about the slope of a tangent, that means we are talking about the derivative. And our derivative formula for the slope of tangent, our f prime, was 12 times the quantity of 3x minus 5 to the third. We're going to take that and set it equal to 0. Well, 3x minus 5 to the third, remember, it's the same thing 3 times. So we really only have one quantity to solve, and that is 3x minus 5. So to set 3x minus 5 equal to 0, solve that, you're going to get 3x equals 5, x equals 5/3. Go back and check the question. It says, find the values of x. Is what we have a value of x? Yes, it is. So x equals 5/3 is the x position at which we'll have a peak or a valley. Be careful, because if the problem says find the point at which the tangent is horizontal, you would have to take this x value and plug it back into the original equation in order to find the y value. On example 3, the problem says find the slope of the tangent line to the graph at x equals 1. We are again talking about tangent lines, so we need to do the derivative. Before we do the derivative, we need to rewrite our original function so that it is a power and not a root. So we need to rewrite this as 3x squared plus 6 to the 1/2 power. Now we can do the derivative. So I'm going to write dy dx just to get you used to that new way of writing derivative. Drop the power to the front. Inside stays the same, 3x squared plus 6. 1/2 minus 1 equals negative 1/2. And then we take that times derivative of the inside, which will be 6x. If you take 1/2 times 6x, you will have 3x times 3x squared plus 6 to the negative 1/2. We are going to need to use this because we need to plug in numbers. So let's make it back into a positive power. Right now it's considered to be in the numerator. To make it positive, we're going to put it into the denominator and make it the quantity of 3x squared to the positive 1/2. But remember what a 1/2 power is. It's a square root. So we can finally write this as 3x over the square root of 3x squared plus 6. The reason I chose to do this problem with you is to see how you can convert back and forth between the square roots and the 1/2s and those type of things when you need to use them. We are asked to just find the slope of the tangent. And the derivative is always the formula for slope of the tangent. So for our problem, the slope of the tangent at x equals 1, we're going to have 3 times 1 over the square root of 3. Now 1 squared is 1, so it's going to be 3 times 1 plus 6. Well, that's going to give us 3 over the square root of 9, which is 3, so we get 1. Example 4 says the total cost in hundreds of dollars of producing X calculators per day is given by the function c of x equals 10 plus the square root of 2x plus 16. After the function, they give us this statement about 0 less than or equal to x less than or equal to 50. Remember that x was how many calculators? When they say this x between the 0 and 50, that's telling you that this function only works for those numbers between 0 and 50. If you were making more than 50 calculators, the function would be different. Question A says to find c prime at x. Find the derivative. Well, we need to recognize up here on the original that that's the same thing as having 2x plus 16 to the 1/2. You are going to be very good at going between 1/2s and square roots. Finding c prime of x, then, the derivative of 10 is 0. Plus, bring the 1/2 to the front, leave the inside the same, 2x plus 16. 1/2 minus 1 is negative 1/2 times derivative of the inside is 2. Cleaning this up a little bit, 1/2 times 2 is 1. We don't need to write down the 0. So our derivative is just the quantity of 2x plus 16 to the negative 1/2. We are going to need to use this as we move forward. Right now it's considered to be in the numerator, so we're going to move it to the denominator, which would make it 1 over 2x plus 16 now to the positive 1/2. We know a 1/2 power is a square root, so our final form of this will be 1 over the square root of 2x plus 16. For question B, it says to find c prime of 24 and c prime of 42 and interpret the results. First, let's do our c prime of 24. We are going to have 1 over the square root of 2 times 24 plus 16. That's going to give you 1 over the square root of 2 times 24 is 48. 48 plus 16 is 64. The square root of 64 is 8. So you get 1/8. Change that to a decimal. You get 0.125. And if you go back to the original wording of the question, in parentheses, it says that this cost is in hundreds. So once you get an answer, you must say hundreds. If I say 0.125 hundreds, that's the same thing as taking 0.125 times 100. So we could say, or 12.5, which if you're talking about money would be 12.50. So what does this mean? First of all, this is a cost function. So we are describing what's happening to cost. This is positive. So that means that the cost is increasing how much? That number we just got, $12.50 when we change, or when changing from, what number did we put in? 24 to the next 25. What were we making? Calculators. We are also supposed to find C prime of 42. If we do C prime of 42, we will have 1 over the square root of 2 times 42 plus 16. 2 times 42 is 84 plus 16 gives us 100. So we'll have the square root of 100, which is 1/10, which can be written as 0.1. And remember, we must say hundreds. If I take 0.1 times 100, I get 10. So the change in cost at 42 is 10. So this time it's cost. It is increasing by $10 when we change, or when changing from 42 to 43 calculators.